Okay, let's start. My screen is visible, right? Hello.
Yes, sir.
Yeah.
Yes.
So in the last class, we have seen the evolution of data networks. A brief history about how the data network or the communication network has evolved. Then in the lighter note, we have introduced the network, internet network, and the communication network. Then we given the differences between the telephone network and the computer network. Then we have discussed the in the network what exactly is the problem, right? So the number of links which are increasing with respect to the number of devices, the communicating devices. So that was the main problem. So the time complexity was order of n square, right? So in order to reduce this time complexity, so we need some kind of a new mechanism, right? So that mechanism is called the switching, right? So switching. Let's start with switching. So in the large networks, if you consider here, just we have considered only the 4 devices in a network, right? And we have the from this device, right? We will be having, suppose you are sending a data from, suppose this is the A, right? And suppose this is the B, correct? Suppose you want to send us some data from A to B, or you want to make a call from A to B, correct? So how many routes we are having? We are having, this is the one route, right? Like this one route will be there, and one is the direct route, and another one is the route from this. Okay? So there are 3 routes are there. Okay? So in order to select which route is the good route, right? Or I want to avoid these links. So this is the one link going to this and coming to here, and this and here to here. So these links I want to avoid. So I need a one kind of a mechanism, right? So selecting a path, selecting the data must take out available options is called selecting a path that must take out the available options is called switching. So I'll give the in in pictorial form, right? Suppose think here this is the BSNL office. This is the BSNL office where switching will be switching functions will be carried out here, right? And there is an input here. So one input is there here, and second input, third and fourth, and so on. So you can see this is the one. And this is the n minus 1, and right. So this is the switching device, right? You can write here. Okay. The main function is to select one options available here. So these are the input, right? So we will connect here. So these are all outputs. These are all outputs, or you can, these are all outputs. And similarly, we output also we are having 1 to n. Correct? And suppose here network is there, and one more communicating device, and here is the one more communicating device. Okay, and this device, or we can connect to n minus 1. This you connect to n. So suppose this is connected here. Okay, and this one is connected to n minus 1. Right? This is A. And B. So A wants to communicate to B, right? So at that time, how the switching will happen, right? So there will be a one connection here. Okay. So these connections, what it will do, it will connect to the exact the option which is connected to this B. So before going to here, I will show you. Suppose this is suppose this is connected here, right? And this connection is connected to here. Right? This is the easy. So whatever the another is, suppose if you are having the one more telephone, then it will be connected to 4, and this 4 is to connect to here, right? And so on. Correct. So now A wants to communicate to B. Okay. So what switch has to do? It has to just connect this link to this link. That's all. It's a function. So from here to here, right? And suppose B, again B wants to communicate to A, then what it has to do? It has to connect from A, from B to n minus 1 to A, right? So it's very simple. So how many links we need total in this scenario? See, in this scenario, how many we need? 12, right? So each has to connect to everyone, all three. So this A needs 3, and suppose this is a C needs 3, and B needs 3, and suppose this is a D, and needs 3 links. So 3 4 is 12. So 12 links here we need, correct? And suppose n nodes are there, we got like total number of links is n square, right? Suppose here, right? So if you are having a n nodes, right? 1 2 3 till n nodes. If you are having, we need just n links, right? So here the mechanism switch is to just connects to the link which are connected to the particular telephone device, right? So here how many we need? Total number of links required in this case is clear. Students, are you able to understand why we need in? Are you able to
So
understand
what
it? Or?
about the two links we are giving inside the switch? That doesn't count.
No, this one only I am saying. See, the switch You want to say that here also one will be there and it will be connected to the other. Like this you want to say?
No, sir, not like that.
You want to say that this is the n links here and here are 2. That you are saying? So
Yes,
total
yes, sir, like that.
n plus 2. Yeah. So this is like a one box. We don't have, you know, it's like a kind of a switch. Okay, switch like on and off. Okay. So for these things we won't count it. We will count the
Okay,
connection between the this link to this link.
okay, sir,
Okay.
yes, got it.
Yeah. Fine. And the time complexity for this case will be the order of because we need this n number of links. So this is the switching mechanism, right? So in the switching mechanism, popularly there are three techniques. There are three techniques. The first one is message switching. Third one is packet switching. Okay. So there are three types of techniques, switching techniques: the circuit switching, message switching, and packet switching. We'll see one by one. The first one we will see is the circuit. Okay. So in the circuit switching, two network nodes, right? The two network nodes establishes the dedicated communication link before they transfer any kind of informations. That we call the circuit switching. Okay, so you can write down two network nodes, or you can think of, so one is the one, this is the one network, A, right? Logic, I want to put this one here. This is the network A, network B, and there will be device A. So this is the A device and this is the device B. Okay. So what I'm saying is two networks. So network A and B. Okay. Two network nodes. Okay. Establish a dedicated communication link through the network before the nodes starts communicating, right? So these two nodes, before they start communicating, there should be the establishment of a dedicated link, communication link, or what you can say is it is a connection oriented network switching. whenever we make a call using the telephone, right? So there will be always the wire connected to the telephone, right? Except the wireless one, right? That is the one of the example for the circuit switching telephone network, right? So a dedicated route is established between the nodes A and B of the different networks, right? Suppose source A wants to send a data to B. Okay, so it has three different phases in order to achieve this kind of a network. There are three phases. Three phases. Suppose we are having the one telephone network, telephone. Third one you can keep here, fourth one here, and create telephone network scenario. Okay, and suppose this is the source, and this is the line, right? So S wants to communicate to D, correct? And we have the possible path like S to A, B and D, or S to E, F and D, right? So two possible routes are available, correct? So how to decide the which route need to be taken, right? That will be physical layer. So I'm not going in detail how to select a route, right? So I will just show how to make a dedicated link between S and D, right? The first phase is circuit establishment, and the second one is data transfer, and is so these are the three steps. I will show you in the diagram. Okay. So the first one is circuit establishment, means the node or the telephone. So first what it does, it will send a request. Okay, it's a request, right, to both parties. Whoever is nearby, it will just broadcast the request packet, and this telephone again it will broadcast that are okay, actually I had given the wrong diagram, so it should be so these are the switching stations. Switching stations. Switching stations. Switching station. And this switching stations will be so route request will be sent to the nearest switching center, and this switching center in turn will forward to the nearest switching center of the destination, right? So like this will be the request. So this is like a route request. So I want to send some data to the D, or I want to make a connection to the D, so I need a route. So all these are route request. Right, so these are all route request. So once this root request is reached here, whichever is comes first, so that is assumed as a shortest path. Suppose this route, right? So S to SW1, SW2 and D is the shortest. Then what D does is it will reply a message. Okay, so this is the reply. So that indicates that I am agreed to preserve this route for you. So this is the reply. So first S will send a route request. So whichever comes first, that it is presuming has the shortest path. Then for that path, it will reply. Route reply will be sent. So once this route reply is reached at the S, then there will be the establishment of dedicated path. So I will mark it as a red color. Okay. So this will be the dedicated path, right? So yeah, this is the dedicated path between S and D. So this is the complete circuit establishment. So our circuit has now established between S and D. Okay, it's clear, students? Am I clear
Yes,
to
sir.
you? Yeah. Okay, fine. So once this is done, right? So next is the data transfer. So next phase is second one. So yeah, I'll just do this. This is and this is the route we are having between S and D. So this is the dedicated route we are. Now the S can make a signal. I mean send the data transfer. Now you can send the data. So you can here. So data transfer. So data will be sent to the D through switch 1 and 2. So this is the data transfer. So the whatever the amount of data, the whatever the amount of time the S wants to communicate with the D, right? That amount of time, this route will be dedicated only to the S, not to anyone else. So this bandwidth is always fixed. Okay, so always fixed. Then come to the last phase that we call the circuit. Okay, so in the circuit disconnection, what we see here, the active entities are only two, right? D and S. So the D and S, they can take, anyone can start, or anyone can initiate the circuit disconnection once they have the enough amount of data transmissions. And if they don't have any data to transmit from S to D or D to S, right, at that time either S can initiate or D can initiate for the circuit disconnection. Otherwise it's a waste of bandwidth, right? Suppose D wants to initiate the circuit disconnection, then this link will be disconnected like this. Finally we will be like as it is. Okay. So this is like these are the three phases involved in the circuit switching technique, right? So circuit switching technique, what it does, it will connect two nodes which are there in the two different networks, right? So before any transmission of data or sending up any signals from S to the D, they will establish this circuit, right? Using the packets called the root request and the root reply. So once the root request, root reply is done, then there will be the dedicated establishment of the root. After the root establishment, then there will be the whatever the amount of data the S is has, then those data will be transferred from S to D through SW1 and SW2. So once the S transfer all the data and it doesn't have any data and it doesn't want to communicate with the D, at that time D will initiate the circuit disconnection request. So according to that request, the links will be disconnected, right? Is it clear?
Yes, sir.
So what are the advantages then? Can you tell anyone what are the advantages of this? Kausalya? Kausalya?
Yes,
Okay.
sir.
What are the advantages in this circuit? Do you know or not?
Sir, we can easily make the path
Easily?
using this step.
No, can you repeat it?
We can easily make the path, sir, for data transfer.
Okay. Krishna Prasad?
Yes, sir.
Yeah. What is the advantage of this circuit? Circuit switching technique?
Sir, um, uh, not sure, sir.
So anyone wants to?
Can take limited amount of data, sir.
We can take limited amount of data.
Sir, since it's having a dedicated path, it might reduce crosstalk and reduces complexity of the circuit.
Yes, this is very good actually. It reduces the crosstalk. And the second one is the applications, like if you want to send the continuous data 24/7, right? So at that time also we need the circuit switching, right? The second one is continuous transmission. Then only the throughput will. There will be not like in the, what I want to say is, after sending a certain amount of data, no need to again request for the route. It's always route will be there. So and if you are sending the continuous data, so no need to again request it, so there will be no delay in that case, right? So steady data, it will be there, right? That's what the continuous transmission is. And the very important one is, so at the beginning only we are having the delay. So this establishment, whatever this scenario is there, right? I have selected, no? So this diagram. So this diagram, what it is? This is the circuit establishment. Okay? So to make or to establish the circuit, whatever the time it takes, right? So that is the only disadvantages here. But there will be no delay in the intermediate nodes or the switching stations. right? Intermediate delays are found once the circuit is established, right? So these are the advantages. Disadvantages. Delay during the circuit establishment might take the delay. So that is the one. The second one, suppose the scenario is like S has only, for example, this link, whatever the link we will be establishing, so that data maximum capacity will be, say, for example, 50 Mbps, right? 50 Mbps is there, but S has only the 10 Mbps. So remaining 40 Mbps bandwidth will be wasted in this circuit, correct? So that we call the underutilization of underutilization of bandwidth. So one of the resource during very low data load, correct? Right. So these two are the main disadvantages here. Okay. So let's start the next one, message switching. So whatever we will be having the communication, right, in the mobile phone, so that kind of a communication will be not possible in the circuit switching. So only application to the circuit switching is, for example, the telephone network. So in the message switching, this is the completely connectionless network switching. So connectionless where the entire message, whatever the message will be created at a node, that entire message is routed from the source to the destination. So one condition is that one hop at a time. Okay. So one hop means, suppose yeah, suppose this is the node. This is the second node. This is the third. So moving from this node to this node, right? So this moving from this node to this node is called the one hop. Okay, this is a one hop. If you move from node A to B, that is a one hop transmission, and B to C, that is the one hop transmission. Okay, clear? So the message switching, it's a connectionless network switching technique where the entire message, whatever the message the A is having, so that message will be routed from A to C. A to C will be routed the entire message, but one hop at a time. So it will first send to the B, then it will wait here, and from B to C, right? Okay, fine. So what it does actually, so suppose node A has a message M. Node A has a message M, and this message, right? Suppose if you consider this is a message. So in this message, there are two parts. So one part is the actual data that we call the payload. So actual data, that is the payload. Then other one, sorry, the other one is the header. So other one is the header. So payload is the actual data, and header, what is this? What is this header? Header means it contains the destination address, the IP address of a destination. So for example, the A wants to send to C, so C is the destination, and so C, node C's IP address, whatever IP address is there, that IP address will be stored in the header, right? So okay, I'll give one more pictorial form, so you will get a better idea. The destination. This is the source, and here is the destination. And these are all A, B, C, and A, B, C. These are all the switching devices, right? Switching devices. Okay. And usually the connection will be like, the connection will be like this. And this will be connected here, and node B is connected to C, correct? And node A can connect to this node. Node A can connect to this node, and node A can connect to node B, and node A can connect to this below B, and C node they can connect. So these are all the possible routes which are available for the S to transmit its information to the node D. Correct? So how many paths are there? So many paths are. So this is the one. The second one will be like this. So third one will be like this. So ignore the arrow marks, right? So think as the both sided value. So both the arrows are both side arrows are, and so it has created the message. So it has created the game, right? Suppose this is the M. M. M1 message it has created. So what M1 message will be doing? It will be selecting this path, any one path. Suppose say this is the shortest path at this time, so it will be moving this way, right? Ignore the arrow mark, right? And suppose you are having the one more message. Time you are maybe sending the both the messages, right? So like these messages are there, two messages. So one already the message M1 this path is taking. So the other message can take any one path from this path or from this path. Say this is taking this. So for me it is easy if I write here. And reaching. Right. So what is the role of this switching? So this is the so all circles are switching devices. So whenever the message M1 comes at here, say for example node A or switching device A, right? So what it does, it will check the complete message. Is there any transmission error or there or not? Okay, if any errors are there, then it will send back to the source S, right? And if it is not there, then it will check, okay, where it has to go. Means it has to see the header, correct? So where is the destination address, right? So that destination address, once it is confirmed, suppose say in this way it will be reaching the destination, right? Then it has to select this route, correct? Suppose see M2 is also sending to the device D, but already switching device A is already sending the information through this, and M2 also has to reach to D, and it has to take this path, but here it's already overloaded. We cannot assign to him, right? Then it will assign to the other path, right? Suppose this path is not leading to there, then what it does is this switching device, right? The switching device, it will stores the message M2 temporarily. Very important. It will stores the message M2 temporarily in the queue, okay, or the memory. So first come first serve, right? Then again the node, it will check whether that path is free or again it is occupied by the previous node. Okay, so if it is not occupied, then what it does, it will forward the message to. That's why the message switching technique is also called as store and forward technique. Yeah, it will store, right, if there is no links available or the link is busy, right? At that time it will store, and later after some time again it will detect the link. If it is free, then it will forward that information, right? That's why they call the store and forward technique. So advantages of this technique is, the first one is they can share the links, correct? Sharing of communication channels to ensure the bandwidth usage. So there is no circuit establishment, nothing. It will directly starts from the data transfer, right? Whichever the device has the data, so that data will be transferred to one among these three links, right? So hence it will what it does, it reduces the network congestion, because the data which is come here, right, and suppose this link is busy and the data is supposed to lose here, right? But what it does, it will store that data for some time, right? So due to that, the network congestion will reduce. Otherwise it has to again send the same data to this switching device, it reduces the network congestion due to store and forward method. And disadvantages. Suppose the messages are very big. See, we are not dividing any messages here. Whatever the message is created by the sources, well, same message I'll be forwarded. For example, the message size will be like 100 Mbps. Sorry, 100 MB. Correct? So the complete 100 MB will be transmitted. And suppose the message is 1 gigabyte. Right? That's a huge. At that time, the switching device cannot handle. So, suppose if this switching device need to handle, they need a big storage device. Correct? So it cannot handle the dead stages of messages at the right. So this is one of the delay. Yeah, one of the issue. The second one is the delay incurred at the switching device due to store and forward method. So certain delay will be there, right? So that delay is the one of the disadvantages here. Okay. So the next one is so this is also a connectionless network switching. So here what it does is whatever the message is created, message which is created by source, for example say M, right? So divided depending upon the rates of the sending link. So for example, this is the one complete message. So this is the complete message. So this message, what it does is, it will be divided. For example, divided with a certain number of cells. So yeah. You can see this is A data and B, C, D and E. Right? The complete message, the packet switching, what it does, the complete message M is there, right? So this complete message will be divided into smaller packets, right? And each packet will be having the payload as well as the header. Correct? So whatever the scenario we have considered here, the same scenario will be considered here also. Okay, the same scenario will be considered. So here also the same scenario, but instead of the complete message, we will be having the chunks of the messages. Like for example, A, right? This will be the B, and one more data is created. One more This thing. Okay. So these three different chunks of the messages. So these three chunks will be, routed to the destination B through various routes. So here there is no confirmed route, right? So at the D, so the ABC can be, not in the same order. A should come, B should come, and C. So in the same order. No, it's not necessary. So they will come in ordered way. So at the destination end, the node D, it will reorder. Okay, so first A has to come, then second B has to come, then second C has to come. Okay. So in the next, I think the time is over. In the next class, I will give in more detail about this packet switching. Okay, I think a lot of time I have spent.